Okay, so unit 4 is exponentials and logarithms. So we're going to start by talking about exponential equations. An exponential equation is an equation that has an integer, well, not usually an integer, but a number base, and then your variable is in your exponent. So, for example, if you had something like 2 to the x, that is exponential. So it's exponential because your variable is in the exponent. Okay? So now, if we had these 2 points and we were trying to find the equation of a linear function, we would start by finding the slope, and that would be 8 minus 2 over 7 minus 2. So that's 6 over 5. Then we would label this x1, y1, and say, okay, 2 equals 6/5 times 2 plus b. So 2 equals 12/5 plus b. So then 2 minus 12/5, math enter, enter. So our b value is negative 2/5. And then once you have your slope and your y-intercept, you say y equals 6/5 x minus 2/5. So that should be review. Now, for an exponential function, the base formula is y equals a times b to the x. So we're going to label this x1, y1, x2, y2. And we're going to get a set of systems of equations. So we would say when x is 2, y is 2. So 2 equals a times b squared. Could you be any louder, dog? And when x is 7, y is 8. So 8 equals a times b to the 7. Okay, well, let's get a by itself by dividing by b squared. So a equals 2 divided by b squared. Then I'm going to take this a and I'm going to replace it with this. So 8 equals 2 times 2 over b squared times b to the 7th. Now my exponent rules say that when I divide, I subtract. So b to the 7th over b to the 2nd is b to the 5th. So 8 equals 2 times b to the 5th. Then if I divide both sides by 2, I would say 4 equals b to the 5th. So then to figure out what b is, I would take the 5th root of 4. To do that in your calculator, you press the math button, and you would use this one right here, the x root, and we want the 5th root of 4. So just like the opposite of cube root is cubed, the opposite of the 5th power is the 5th root. Would they say 4 decimal places? And then once we have b, we would come back up here. I'm going to write this over here. So then 2 equals a times 1.3195 to the 2nd. So 1.3195 squared, 1.7411. And then divide 1.1487. That was really annoying. I wonder if there's an easier way. Oh wait, yes there is. Times. Okay, I just did that the wrong way, just to show you. The short way is to use the calculator. So if you remember correctly, we have a function in stat that will find equations for us. So for example, if I clear everything out of here, I missed one, and I put in my two x values, so that's 2 and 7, and my y values were 2 and 8, and I go stat calc linear regression, it gave me that 6/5 x minus 2/5. And so the good news is that the calculator will also do an exponential regression for you. So if you go to stat and calc, instead of linear regression, we're going to scroll down and see how right here, the next one off the screen is exponential regression. So enter. And then see how it's 1.1487, 1.3195. So if you hate everything that I just did, because it's not my favorite way to do it, all of this I mean, then you can use that stat feature in your calculator to find those equations for you. Okay? Now, finding the equations does become a little bit easier if one of your points is the y-intercept, because if this was x and this was y, then it would be 5 equals a times b to the 0. And we know that anything to the 0 power is 1. So we know that a is 5. And anytime they give you the y-intercept, that number, that y-intercept is going to be your a value. Excuse me. So now that I know a, I can plug this x and this y in with that a and say 135 equals 5 times b to the 3rd power. 135 divided by 5 is 27. And then since this is the 3rd power, we would want the 3rd root, which is right there on my calculator. It's the 4th option in math. The 3rd root of 27 is 3. So b is 3. So my equation is y equals 5 times 3 to the x. Now, again, you didn't have to do it this way. You could again have said, okay, stat, edit, it's only 2 points, but that's all the calculator needs. 0, 3, those are your 2 x values in L1, 5, 135, your 2 y values in L2, and then stat, calc, down to exponential regression. Press enter a bunch of times. So see how it was the same thing that I got, 5 times 3 to the x. Okay? So the calculator is always an option for these if you do not want to deal with math. Okay, so to determine whether a function is linear, you need to look for a common slope. So for example, this went up by 1 and this went down by, what is 16 minus 24? 36. This went up by 1 and then 24. This went down by 32.8. So see how the ratio here is not the same? So this is not linear. To see if it's exponential, you're going to do something fairly similar where you're going to look for, is there a number, a constant number that I'm multiplying by? So we would do what is, instead of 60 minus 24, we would do 24 divided by 60. And then negative 8.8 divided by 24. Negative 39.04 divided by negative 8.8. Oh, hang on, I messed that one up. Negative 39.04. I feel like wait. I don't know. I honestly never do these by hand. I always just put them in the calculator. So I would always just go stat, edit. So here you're just looking for an R value of 1. 1, 2, 3, 4, 60, 24, negative 8.8, negative 39.04. So you go to stat and then calc and you do a linear regression. That R value, if that R value has to be 1, the R squared value. The R value can either be 1 or negative 1. If it is anything else, then it is not linear. And so then it would be the same for the exponential. What did I do? It should not have given me a domain error. Stat, calc. Oh, okay. It's because those were negative. Well, getting an error means that it's neither. It's definitely not exponential either. So like if we do this next one, okay. And we come over here and we make this 80, 64, 51.2, 40.96. And then we go stat, calc, and we try our exponential regression. You see how that R value is, the R squared value is exactly 1. My R squared value is exactly negative 1. That means that this is exponential. And so then if we look at this last one, stat, edit, we're going to do 80, 60, 40, 20. If we go to stat, calc, and then exponential regression, see how that R value, R squared value is not 1. R value is not 1 or negative 1, so definitely not exponential. But on my linear regression, you see how my R squared value is 1 and my R value is negative 1. So that makes this linear. So yeah, I mean, you could check ratios, but IMO, that gets annoying. So I just use the calculator. Now, finding the equation for an exponential is going to be the exact same as I showed you on the other page, only you have to get 2 points. So I'm going to say that I have a point here at 0, 3, and I have a point here at 1, 6. And now, because that's the y-intercept, that means that my a value is 3. So then I would say 6 equals 3 times b to the 1. Well, b to the 1 is just b. So b is 2. So y equals, or in this case, is that a k? k of a equals 3 times 2 to the a. And again, if you didn't want to do this, you could have just plugged these two in and done the stat function. Okay. The graphs, this is the basic shape of a graph of an exponential function. Because of transformations, it could flip over the y-axis and it would be like that. It could flip over the x-axis and it would be like this. So we have 4 different possibilities. And these depend on my a value and my b value. So this is the case when a is positive and b is greater than 1. And this is the case when a is positive, but b is in between 0 and 1. So this one is that a is negative and b is greater than 1. And this one is that a is still negative, but this time b is between 0 and 1. So in this case, we have our a value is negative, and our b value is greater than 1. So that means I'm looking at a graph shaped like this. So as my t values go off to positive infinity, my y values go down to negative infinity. Now, this is where we need our transformations. This is going to have shifted the graph up 2. So a normal exponential function has an asymptote at y equals 0. Because this shifted up 2, this one's asymptote is at y equals 2, which means that on this side, it's going to approach whatever that number is right there. Now, if that was a lot of math for you, you always have the calculator. So let's take a minute to graph this and see what it looks like. -5, 2 to the x plus 3 plus 2. So see what I mean about this was the basic shape? And you can see that as we go this way, those y values are going to go down to negative infinity. And as we go this way, if we look at the table, because it's kind of hard to see on the graph. Oop, I'm going the wrong way. Whoops. Oh, I did them backwards. Stupid Moore. It always does right hand on the top and left hand on the bottom. Lame. All right. Anyway, on this
that
side,
drives me crazy, by the way.
I don't blame you. That was annoying. That was definitely not me. Because I was even saying, like, on this side, as t goes that way, it goes down. And then if you look, like, you can straight up see how these numbers are getting so close to 2, and then finally the calculator is like, hey, I can't do any more decimal points. It's never actually going to reach 2. This is like 1.99999, and then 1.9999999. But the calculator is just rounding at that point, and it gets to 2. So if you're not sure, then again, you could always graph this and look at the table, and that way you know exactly which number it is. But I'm here to tell you that it's going to be whatever number is out here behind a plus or minus. So if this had been a -6, then this would be a -6. If this had been a plus 17, then this would be a 17. Okay. So the thing that I like about this section in particular is that if you wanted to, you could solve every single one of these, except for the last one. You could solve every single one of these using that stat function in your calculator. and just let it find all the equations for you, which I think makes life easier. But that's just me. Okay, so then the other part of today's notes was the beginning of logarithms. So logarithms and exponentials are inverses of one another. That means they undo one another. So if we have a log with base b of x equals y, we could rewrite this exact same equation as b to the y equals x. So these two statements are equivalent. And so if I ask you log base 3 of 81, what I'm asking you is 3 to what power is 1 over 81? Well, 3 to the, let's see, it's 3 to the 4th power is 81. So then 3 to the negative 4 would be 1 over 81. All right. You hated that. I know you hated it. You don't have to say it. In your calculator, if you press math and you scroll down, you see right here, I went too far. See right here, it says log base 3 of 1 over 81. Now, if you have a TI-83 and you do not have that log base option in math, then you would do the change of base formula, which is that the log, I got ahead of myself, the log with base b of x is the same as doing the log of x divided by the log of b. So again, if you don't have a TI-84 or your TI-84 is old and it doesn't have that log base as an option, then you could do the log of 1 over 81, not 18. And by the way, when I say the log, I'm just using this button right here, divided by the log of 3, and then press enter, and see how it got me the same -4. So again, this works if your calculator does not have log base. If your calculator has log base, you can do this. So then all of this just becomes an exercise in do I know how to use my calculator? So math, log base 5 of 1 is 0. And that is because 5 to the 0 power is 1. Okay, log of the square root of 64 divided by the log of 4, 1.5. And then 8 to the log base 8 of 3 is 3. So here, if you have a log and the log is in an exponent and this base and this base are the same, they cancel. But again, all of that is a calculator exercise once you know. Okay, so then E, we've talked about, E is a special base for exponentials. I'm sure Andy went into an explanation. And then ln is log with base E. So E and ln are inverses of one another, which means that the ln of e to the -11 is just -11. And e to the ln of 5 is just 5. So anytime there's an e and an ln next to each other, they cancel. E to the ln of the square root of 3 is just the square root of 3. And now here, you'd have to know that you have to flip this back up. So you would rewrite this as the ln of e to the negative 5, and that would just be negative 5. And if you didn't know that, then we have the ln and the e buttons in our calculator. So you could just do, there we go, the ln of 1 over e to the 5. Okay, so there's your log button, there's your ln button, and your e button is second and then ln. What the heck, Cisco? It's gonna kick me off in 5 minutes. I guess it's only giving me 40 minutes. All right. We'll probably have to restart. So this would be the same as log with base 4 of a equals y. Log with base e of c equals a, but log with base e is ln. And then to write this as an exponential, we go the other way. C to the b minus 1 equals p minus 6. Okay. So to find the inverse of this, we do the same steps as we did before. Make it y equals 5 to the x plus 2 minus 3. Change that to x equals 5 to the y plus 2 minus 3. Add the 3. Now, we're trying to solve for y, so I'm going to turn this into a logarithm. Log with base 5 of x plus 3 equals y plus 2. Log with base this of this equals this. And then we'd move the 2 over. So the minus 2 would be on the outside of the parentheses, and that is your inverse. Okay, logs have a special rule where you cannot put negatives into logs. So if we're worried about the domain of a log, just like with, you can't put 0 in either for logs. So we would do this similar to how we do the square roots. And here to solve for the domain, we would say, okay, well, we need to know where is x plus 9 greater than 0. So my domain is everywhere x is greater than negative 9. So just like with the square roots, only with square roots you would say greater than or equal to. With logs, you just say greater than. So then this would be negative 9 to infinity. The range for every logarithm is always all real numbers. Say that one more time. The range for every logarithm is always all real numbers. And logs always have vertical asymptotes. So this would be vertical asymptote at this number right here. So at x equals negative 9. So whatever you get right there, that's where your vertical asymptote is. And for logs, it's always a vertical asymptote. For exponentials, it's always a horizontal asymptote. For logs, it's always a vertical asymptote. And then your number here is always whatever number you got right there. Okay, well, I ended like right before it's going to kick us off, so I have to end the meeting and then restart the meeting anyway. So I'm going to let my video do its thing, and then you guys should all be able to jump back in.